Assalamualaikum. My name is Tengku Ukri bin Tengku Waka. And my group name is Muhammad Arish bin Yasaini and Muhammad Ikwan Syafiq bin Nur Syam and lastly Hassan Basri bin Ibrahim. So for our case study, we will be present about agriculture in this industry. So I will pass to Muhammad Ikwan Syafiq for our first presenter.
So, Assalamualaikum sir. Good morning. So I will present the introduction. So the future of agritech, Meranti latest edition in AI Park, where various facility will support the testing and development for AI enabled technologies. The sustainable urban farming facility aim to drive acceleration and adoption of AI in agriculture sector. So the agriculture industry may increase crop yields, cut expenses or costs, and better use resources like water and fertilizer. So artificial intelligence in agriculture include precision farming, which utilize sensor data and machine learning algorithm to optimize crop planting and management. So next, artificial intelligence can potentially revolutionize how we optimize food, making it more sustainable and efficient. So for the right side is a example AI implement in agriculture. So first planting drone, second system monitoring crops, autonomous tractor without driver, so agriculture, and last agriculture robots. So for the next slide, the implementation of artificial neural network ANN. So crop yield prediction involves training an ANN with historical data on weather, soil conditions and other factors to forecast a crop potential yield. Crop disease detection involve analyzing image of crop to detect symptom of disease or pest using computer vision technique and artificial neural networks. Precision farming is a type of farming which ANN are used to optimize crop planting and maintain. So for the crop disease example AI implement in agriculture will be the next slide. So I will pass to Arich. Thank you, sir.
Okay, thank you, Ikwan. Okay, I will present about benefit implementing artificial neural network of agriculture industry. We have 7 benefit, which is increase crop yield, reduce cost, improve sustainability, good decision making, increase efficiency, increase food security, and energy optimization. Okay, for the next for the next slide is training data requirement. Okay, soil sensor, drone and other monitoring device to train an AI model for soil sensor, drones and other monitoring device. It will be beneficial to collect data generated by this device during using field operation. This data can include measurement such as soil moisture, content, nutrient level pH, temperature and other relevant parameters. Additional data from drone imagery including aerial photos and multi-spectral image can provide insight into crop health. Vegetation and other visual indicator, combining this data set with a corresponding ground truth measurement can help train the model to interpret and analyze the sensor and drone data accurately. Okay, second, data on crop yield, disease and pest infestation and other factors. To training data that incorporate information on crop yield, disease occurrence, pest infestation, and other relevant factor is available for developing an AI model in agriculture. This data can be collected from historical record, agriculture survey, and farmer report. It should cover different crop type growing regions, session, and management practice. By exposing the model to this data, it can learn to recognize pattern, recognize pattern by managing practice, identify potential yield limiting factor, and provide insight into disease and pest management strategies. Okay, for the third is weather condition, soil moisture, temperature, and other factors. To include data on weather condition, soil moisture, temperature, and other relevant factor in the training data is crucial for building an AI model that understand their impact on crop growth. Historical weather data obtained from meteorological agencies or weather station can provide information on precipitation, humidity, wind speed, and solar radiation. Combining this with soil moisture data, temperature and record, and other environmental variable enable the model to learn how different conditions affect crop development, water requirement, and other aspect of agriculture. Okay, this is example of data training in agriculture using crop monitoring. Precision agriculture use AI technology to aid in detecting disease in plant pests and poor plant nutrition on farms. The eye sensor can detect and target weed and then decide which herbicide to apply. Okay, that's all from me. I pass the slide to the next presenter.
Thank you, Muhammad Arif. So, is Sabati. So, for the artificial neural network architecture and optimizer, so firstly is a neural network. First, crop yield prediction using a feed-forward neural network. A feed-forward neural network architecture multiply hiding layer commonly applied for yield prediction. The architecture consists of n input layer, one or more layer, and n layer. Each layer contains a set of artificial neuron or nodes connected to the neuron in the adjacent layer. So, secondly, crop disease detection using a convolutional neural network (CNN). Convolutional neural network (CNNs) are particularly effective for image-based tasks like crop disease detection. CNN process data rich structure such as images. The architecture of CNN typically includes convolutional layer, pooling layer, and vertical layer. So, third, precision farming using recurrent network. Recurrent neural network will for sequential data analysis, suitable for precision farming of Arif. Can you off mic? Okay, thank you, Arif. Third, precision farming using recurrent neural networks. Recurrent neural network (RNN) were suited for sequential data analysis, making them suitable for precision farming application that involve time series data such as crop growth monitoring, irrigation scheduling, and yield forecasting. Okay, for the optimizer play a crucial role in training neural network by updating the model's parameters to minimize the loss function. Two commonly used optimizer are stochastic gradient descent (SGD) and ADAM. So, firstly, stochastic gradient descent (SGD) is a widely used optimization algorithm for training neural network. It aims to find the minimum of the loss function by iteratively updating the model's parameter based on the gradient of the loss function with respect of those parameters. So, secondly, ADAM. ADAM is adaptive moment estimation. ADAM is an adaptive optimization algorithm that combine the advantages of both adaptive learning rate method and momentum method. It is well suited for a wide range of deep learning tasks. So overall, the choice between SGD and ADAM or other optimizer depend on factors such as the specific task, the characteristic of the dataset, and empirical performance on the problem at hand. Experimentation and fine-tuning may be required to determine the best optimizer for a given neural network. So the next slide, please. Okay, for the next slide. Mean square error, MSE, several other criteria are commonly used for evaluating the performance of machine learning model. Here, first is a coefficient of determination, R squared. The coefficient of determination, also known as R squared, is a statistical measure that evaluate how well a regression model fit the data. It provides an indication of the proportion of the variance in the dependent variable that is predictable from the independent variable. R square range from 0 to 1, with 1 indicating a perfect fit. Second is root mean square logarithmic error, RMSLE. Root mean square logarithmic error is a metric commonly used for tasks involving exponential growth or logarithmic scales such as predicted sell or click-through rates. RMSLE concludes the root mean square difference between the logarithm of the predicted value and the logarithm of the actual value. Okay, third is area under the ROC curve. The area under the ROC curve is a performance metric typically used for binary classification problems. The ROC curve plot the true positive rate sensitivity against the false positive rate at various classification thresholds. The AUC ROC represent the overall ability of a model to distinguish between positive and negative sample across all possible thresholds. Okay, lastly, for F1 score, the F1 score is a metric that combines precision and recall, providing a balanced measure of a model performance in classification tasks. Precision represents the proportion of correctly predicted positive instances out of all predicted positive instances, while recall represents the proportion of correctly predicted positive instances out of all actual positive instances. So each criterion has its own strength and weakness, and it is appropriate for different evaluation scenario. The choice of criterion depend on the specific task, the nature of the data, and the desired evaluation perspective. It is important to select the most relevant criterion to assess the performance of model accurately. So for the next slide, I'll pass to the Mukri. Thank you.
Okay, thank you, Hassan Basri. So, I will present about the conclusion in our case study. So, what we can say is artificial neural networks can be used in a wide range of applications. So, such as it can also increase crop yields. ANS have the ability to analyze large amounts of data and extract meaningful patterns. So it will enable farmers to optimize crop production by leveraging and as farmer can make data-driven decisions regarding planting schedules, irrigation and fertilization and pest control. So other than that, it also can reduce costs by utilizing as farmers can optimize resource allocation and reduce input waste. For example, NS can help determine the optimal amount of fertilizer or pesticide required for a particular crop to leading a cost saving and more efficient resources. And it also will improve sustainability and NS can aid in implementing precision farming techniques, which involve targeting specific area of field with precise amounts of input based on real-time data. This approach minimizes the use of resources such as water, chemical, while maximizing crop productivity. And lastly, it will also increase food security. And artificial neural network can contribute to increase food security by improving crop yield predictions and disease detection. But we also need to be careful and make a consideration to the data requirements such as architecture, optimizer, and evaluation criteria to ensure that the models are robust and accurate enough to be used. That's all. Thank you.